Hi, my name is Josh Twist and I'm a program manager on the Windows Azure Mobile Services team. If you've seen mobile services before, then you'll have seen how huge a focus the team has on simplicity and ease of learning. You've probably already seen our quick start, which gets you up and running with a connected client application talking to that mobile service in a matter of minutes. Maybe you've even seen the recent addition of support for Android alongside iOS, Windows Phone 8 and Windows Store, where we have native clients to make working with that mobile service super easy. However, what I want to show you in this video is how that simplicity is more than one layer deep, and that lying behind those client SDKs is a wonderfully simple HTTP API. So what I'm going to do is show you how to do some common operations similar to you would do in the quick start, but using the HTTP API directly. To do that, I'm going to use a little tool called Postman, which is a free plugin for Google Chrome. That's a really great way to play with a REST API. So I'm just going to launch this now. And here's Postman. And in order to start playing with my HTTP API, I need the base URL of my service. And I call the service today HTTP demo. And on the dashboard, I can grab my base URL. So I'm just going to copy that. And the first thing we're going to do is try and do an insert into the to-do item table that we typically create during the quick start. So my URL here should be /tables/to-do item, which is the name of my table. And I'm going to do a post. And since we work with JSON, I need to specify the content type to be application/JSON. Now I can embed my JSON right here. So I'm going to add some text, which is the name of my to-do item, say hello via HTTP, and I'm going to add whether the item has been complete or not, and say that that's false, so I've not completed that to-do item. So let's try and insert this data, and let's see what response we get. And notice down here how we get a 401 response indicating that we were unauthorized. And I can explain that by taking a look at the configuration on our table. So let's click the Data tab, click on the To-Do Item table, head to Permissions, and notice how all of the CRUD operations are set to anybody with the application key. Now, we weren't providing the application key, which is why we were being told we were unauthorized. I can fix that by simply setting insert to everyone, which basically makes that post operation open and completely public. So I'm going to save that change. I'm going to pop back to Postman and hit send. And oh, the change hadn't saved yet, so let's wait for that change to save. There we go. And I hit send again now, and now we're assigned an ID. So notice how I get the object back with any changes. So I've actually got a new ID there of 1 for this new object that I just inserted. Now, maybe I don't want to make that completely open. Maybe I would like people to have the application key when they're making calls to my backend service. So let's set that back, and let me show you how you can do that using the HTTP API. So I go back to the dashboard, click Manage Keys, and notice here is my application key. So I'm going to copy this to the clipboard, head back to Postman, and add another header here, x-zumo-application, and paste in my application key. And this time when I send, we should see, yep, I get a successful insert, and there is my ID of 2 that's been assigned to the object. So now we're working with the application key. I should make a note here that you shouldn't think of the application key as being a security feature of your service. It's a very common ask for people building mobile apps to try and create a slightly stronger tether between their client apps and the service, and they often do this by embedding some unique token into the application. Now you should be very aware that it's very easy for even the most trivially competent of hackers to get that application key out of the package itself, or by simply sniffing the wire when they've installed the application on their device. Now, the application key is useful, however, before you've launched the application, because at that point it is still effectively a secret. But the minute you've put that application out there into the hands of other users or onto the App Store, then that is a public piece of information and really can't be relied upon to guarantee that the person hitting your API actually has your client application, or hasn't indeed augmented that client application in some way. So just be aware of that. What I want to show you now is how you can use the HTTP API to add additional properties using dynamic schematization. So I'm going to add another property here called foo. And we're going to set that to 4. I'm just going to insert that now, and notice how that seems to have worked really well. So let's go and have a look at the database and see what happened there. So switch back to data. You can see there's our item, and we now have this additional column here, foo, which has just one row with the value 4. And that was created thanks to this feature called dynamic schematization. But it's actually possible, if you wish, to turn that off, maybe when you go to production. So I'm going to turn that off and save that change. That's going to deploy live to my service right now. And then if I try and add another property, now that I've turned off dynamic schematization, notice I'll get a 400 response from the service that says it couldn't save the item because it contains a column that's not in the schema. So let's remove that. And let's go and turn dynamic schematization back on. Because the next thing I want to show you is how we can act as users using the HTTP API. So what I'm going to do is set my permissions for my table to require users to be authenticated. So I'm going to do that for all of my operations. So we're now kind of beginning to lock this down and making a requirement that a user has at least logged on to the database before making a request. Okay. And now over on Postman, if I make a post to this, you'll see that we actually get a 401 response that says I'm unauthorized. Oh, in this case, actually, I've made a mistake there, and that's a bad bit of JSON. So I'm just going to send that again. And this time I get the expected response, which is a 401 that says I'm unauthorized. And that's because I'm not identifying as a user. I'm only identifying as the application. And to identify as a user, then I have to use one of our built-in identity providers, Google, Twitter, Microsoft account, or Facebook. In this case, I've pre-configured the mobile service with the client secret and client ID or client key for a Twitter application. So my service is ready to log people on as Twitter. And we can actually simulate that OAuth flow, or actually go through the full thing, in fact, that you would normally see pop up in a hosted web browser, simply with a little bit of knowledge about the way that the OAuth flow works for mobile services. So I go to HTTPS, and I type in the name of my service, .azure-mobile.net/login/ the name of the identity provider I want to use. So in this case, Twitter. And this will actually start the OAuth flow and will direct me to Twitter. Now I've already logged on this machine, so it recognizes me. So I'm going to authorize the app, and that's it. It's finished now. It's actually logged me into mobile services. And in doing so, it's handed me back a token in the URL here. So I'm going to copy this, and this is actually a pretty long piece of information. This is, at the moment, a URL encoded JWT or JOT token. I'm going to decode that using this free online decoder, and that's just URL encoded. And notice that what's inside there is a piece of JSON, and part of that JSON is an authentication token. That's our JOT. So I'm just going to copy that, switch back to Postman, and I'm going to add a new header, x-zumo-auth, that contains that JOT token. And so this time when we do an insert, we should see that we get a successful insert. And there we go, we got our ID of 4. So to prove to you that the service is indeed aware of who I am now, I'm going to switch back to mobile services, go to the data tab, and I'm going to add a script. And so in insert, what I'm going to do is add a new property to the item as it's being inserted. This is the user ID. And I'm also going to add a created date. So I'm assigning the user ID of the current user as a property to the item that's being inserted. So I can keep a memory, in the database, who actually inserted each item. So let's switch back to Postman and insert that again. And notice how here in the results, I'm actually getting back the user ID and that additional created at property sent back to my client. And that allows the client to be aware of changes that you made on the server. That's the default behavior, and you can use script to strip those properties if you don't want them coming back to the client. So let me just show you how you might do that, for example. So I'm going to switch back in here, and then what we're going to do is remove the user ID before we send the response. So I'm going to say delete item.userid. That will remove that property but won't remove it from the database. And then I say request.respond. I just want the canonical response. Hit save, and now when I insert from Postman, you'll see that we get the created at property, which was added on the server, but we don't get the user ID property, which is a useful technique that you can also apply to the read operation on a table. So now we've looked at inserts, maybe it's a good time to take a look at reading data, for example. So I'm going to change our operation to a get, and in this case I don't specify a body. And I'm going to do a get request, which, as you can see, focused on the to-do item, tables, I get back an array that contains all of my items. And of course, if I wanted to apply some security here, I could add a read script that augments the query to say make sure that somebody making a query can see everything they want to see, provided the user ID column on that items table is the user ID making the request. So let me save that, and let's run that query in Postman again. And notice now we only get the 2 items that are actually tagged with my Twitter ID in this case. So that's how we can do queries using the HTTP API. What about updates? Well, to update records in mobile services, we support patch. And a patch allows us to do a partial update to an item. So let's take a look at one of these items here. Let's say we're going to update this record. Now notice it has an ID of 5. So what I'm actually going to do is tag on here to our URL /5, which says I'm going to patch that item. And then I'm going to set the complete value to true, and I'm going to say updated this item for the text. Let's send that, and it looks like it worked. Now let's go and see by looking in our browser window to see if we actually changed the text inside that. And there you go, you can see we updated this item. What I want you to notice though is we didn't change the user ID or the created at because we did a patch, which allows for a partial update. So I can update all or just some of the properties using that API. Finally, let's take a look at delete, which is actually very straightforward. All I have to do is change this to delete, make sure I specify the ID here, hit send, and that's going to remove the item and send back a 204 no content, which is the correct response. So to prove that, let's just refresh our view in the browser window here, and you'll see we no longer have an item 5. So that's us deleting the an item using the HTTP API. What I'd like to show you next is how we give you full control over that request pipeline. So you can employ a technique that we call virtual tables that allows you to short circuit the actual write to a table altogether. I'll show you how that works. So here on my insert script, I currently call request.execute, which says go ahead and insert the data into the database. And because I specified a success handler, I actually ask for a callback before the data makes its way back to the client. And then I call request.respond to send back to the client. Now I could just skip most of that and jump straight to the response, thereby skipping the whole database step and creating a virtual data API. So I'm going to do something completely different here. And what we're going to do is just log the item that's being inserted, console.log item. And I'm going to request.respond with a 200 status code and a string hello world. And that's my response to a post on my tables/to-do item resource. So let's save that and show you what that looks like. So I'm going to just remove that 5, change this to a post, and I can put pretty much any JSON I want in here now. So foo testing, and when I hit send, what I expect is a 200 response that sends me back the message hello world, and if I look in my logs I should see a foo testing object. So there we go, we got the string back hello world, we got the 200 response. If I take a quick look in my logs, at the very top of those logs, I should see foo testing. So it worked exactly as we suspected. But notice if I go back to the database and look at the to-do item table, I haven't created any object that looks like the thing I just threw at the HTTP API. Quite the opposite. I actually short-circuited the database altogether. The last thing I want to show you is how you can make calls. This is great for server-to-server scenarios where you have another backend that wants to call a mobile service and you have a trust relationship with that. Maybe you own the other service. And in that case, you can actually call the service using this thing called the master key. So I'm going to remove my application and auth key. And if you remember, our tables actually have the setting of must be an authorized user, an authenticated user. So if I hit send here, we'll get a 401 that says we're unauthorized. Even though it's a virtual table, those rules are still implied. Now, for this scenario, I'm pretending to be another server making a call into my mobile service. So I'm going to go and grab my master key by going to the dashboard, manage keys, let's copy that key. Let's go over to Postman and type in x-zumo-master. Paste in the master key. And now when I hit send, the right thing happens. It actually comes back and says, hello world. Now, this is great if I want to use the service to, say, send push notifications from another service. Or, on the other hand, if I just want to work directly with the data and ignore scripts, I can even do that if I'm using the master key. So I can simply add a bit of script here that says no script equals true. This will only work if you have the master key, and that disables the scripts on that mobile service for this request. So I'm going to send this now, and you'll see that we got an error. Now, why is that? Let's take a look in our logs. And that's because I inserted, so this is where logging comes in useful. That's because I inserted the wrong data type for my foo object. If you remember, the first time we created the foo object, or the foo column, it had a data type of number, and I just tried to insert a string. So let's fix that very quickly. You see what's happened now is we've skipped that script that was registered on the server, and we're actually using we're actually just working directly with the data and turning off the scripts via the master key. So hopefully you've seen just how easy it is and how powerful it is to work with the HTTP API directly. And perhaps more importantly, you've seen how you can create a powerful and easy JSON-based HTTP API for your clients, whether they want to work with data or whether they just want to execute scripts on the back end, or even if you have another service that wants to work with your mobile service to execute scripts or work with data directly. You're pretty much covered.